All right. I literally have more people overseas than in Singapore. So for the four of you all watching this recording, today's lesson is deliberately such that if you haven't managed to watch this recording, even after we do our next week's class, you will be fine. Okay? So there won't be any like rollover kind of stuff, but still need you to watch this recording to catch up on certain concepts to consolidate for energy. Okay? Anyway, just to lay out today's plan just okay, today we are going to look into your energy worksheet, which I asked you all to complete as homework, the three questions. Okay, we will discuss them in detail, discuss them how to break down, how to answer, so that you're going to be ready for four more questions, which you will take as a mini test today. You know, I always take the, I'm going to do it. Yeah, I hear that. Really? Yeah. Okay. Oh, okay, can. So it has been reduced to three of you. Okay, yeah, very nice. Do you bring your homework? Yeah. How's your trip? Huh? Okay. Is it something that happened? No. Okay. Yeah, not bad. Oh. Energy worksheet one. Question 12, 13, 14. Okay, very nice. I didn't know that you were coming too. Okay. If not for Brandon, Ian, and Tristan, let's follow along with the recording. Right. Anyway, as I was saying, today's brief layout of the plan, we will go through these three questions in detail, and I need you to register them very well because today there will be four structured questions as your energy test consolidation. Okay? If not, we will go through finish energy worksheet one first. Energy worksheet two is stated at the back, right? Yeah. Okay, those questions we will also discuss, but not today. All right. If not, let's move straight into question 8. I don't think I need to assign any time for you to try this, right? But even if you didn't manage to try, sorry that I didn't like allocate time for you to try and class anymore. Okay, because I have more questions for you to try. Okay, let's look at the breakdown of the question first. If you typically struggle in the breakdown of the question, this is for you to understand how to do it going forward. Okay, question 12, we take a look at the figure 12. If I show you a track for a model car, if you see height like 0.4, height like 0.4, height like 0.5, immediately you should be linking it towards GPE, which I think most of you are comfortable in doing. If you still don't get your calculation questions correct, right, most likely you are being careless at certain points. And we have already addressed that carelessness in the form of if there's an initial speed, you will need to have initial kinetic energy. Okay, but nothing too crazy here. If I start from this entire track TSR, QP, whatever. Okay, imagine this situation first, even before you look at the question. If I look at point S here, if I just start from rest at point S, where's the highest point that I will be able to go to? Q. You are assuming, what assumption are you making when you make this? Air resistance negligible, not enough. What else? Negligible, friction negligible. Basically, no resistive force. Very nice. Okay. Am I able to make it to P? Yes. By logic, if I push it forward, I should be able to make to P. What are you doing when you push it? Which gives you more energy in terms of kinetic energy, right? Very nice. Okay. So currently, they say car is released at Q. Okay. Instead of going this way, going the other way. Okay. When you see this release at Q thing, what's your first thought? GP, sure. So there's no K, you do? You think? Right? Hmm. And how do I calculate the K? Or rather, let me get you back to the correct thinking. Release at Q means what? Do I drop it or do I give it a push? Drop. What's the initial speed when it's released at Q? Zero. Right, release at Q immediately, you should get used to this. Q equals to 0 meter per second. What is U? Are you familiar with this symbol? U stands for initial velocity. I'm bringing you back to kinematics. If you think that kinematics is like dark and dusted, it's not. Nothing. Huh? You know nothing about kinematics? I don't think so because I remember your very first lesson that you came, we were discussing kinematics. Maybe like yeah, you are not a ground zero for sure. That's what I okay. Okay, so car being released at Q should be initial velocity zero. This should lead you to think that oh KE, I know that it's zero, the very start. Okay, question. Come to rest just before it reaches S and rolls back. Explain in terms of energy transfer, why it cannot move past S. Pretty similar to what we discussed. If we release at S, Adam said only can reach Q. If I release at Q, I only can reach S. Okay, so explain in terms of energy transfer, what kind of energy do you think will be? Sorry? GPE and KE. GPE and KE will definitely be involved. We take a look at the first one first. Definitely it cannot be released to why definitely cannot move past S, right? Question didn't tell you that the entire thing is smooth. Question didn't say air resistance friction is negligible. Therefore, the key phrase if you are struggling with keywords typically in exam, time for you to pick up key phrases in energy. I think Jaden, you have that problem that you was citing, right? The calculation question usually you can do. Okay, so things like this are energy dissipated into the internal store of surroundings. This is very standard phrasing. This is equivalent to, you don't need to write this down, but the energy loss to surroundings. Okay, if you are able to visualize this a bit better, this is your energy loss to surroundings. But you cannot write this anymore in exam. Okay, so it's really on the energy transfer, energy dissipated into the internal store of the surroundings, and what kind of goes to the environment in the heat and sounds cannot. Okay, even though your understanding is correct, in the new model, cannot really. Right. No. Surroundings and car. Okay. So what is happening is there's the energy transfer to the internal store of the surroundings and the car. Basically, you can think of it as, at the start at Q, the car had GPE. When it reached S, it should have less GPE than expected because along the way, when the car moves down, energy dissipated to the surroundings in the form of internal energy. And where does this internal energy go to? Surroundings and car. Okay, so there's not enough GPE or KE to move past S. Okay, so keywords here, energy dissipated into the internal store of surroundings and the car in the form of these two friction, air resistance. Okay, so now Adam got the correct idea, but if you just mention air resistance, again, you'll be marked down. In maths, sorry? In maths, also in maths. No, in my answer. Oh, in your answer. Okay, good. Yeah. So air resistance and friction. Very nice. Okay, this will avoid you the one. Okay, but if you never talk anything about what we initially talked about, we established that there should be GP, there should be KE, then you will not be awarded the full marks. Second point comes from energy transfer from the GPE at the initial Q is going to be less than the GPE S. Energy transfer from the GPE is any energy that's transferred from the GPE to KE will be insufficient. Therefore, cannot move past S. The point is you have to link it back to this. Yes. There will be not enough energy. There will not be enough energy. Instead of insufficient energy, of course can have that. Okay, but you need to bring in this green color portion for sure. Okay. Yeah. You should do it. Yeah. Okay, let's go. Part B. Second part, mass release from P. If we are talking about the blue color point now, why did I purposely highlight this in blue or anything? In order to show myself very clearly the things that I need to use for calculation. To cut out on the careless error. Mass 0.12 kg will be super useful on energy because I can calculate GPE, I can calculate KE both. It release from T continues until it runs off the track at T. Okay, calculate the maximum speed that car T could have at T, assuming friction is negligible. Okay. Don't know whether y'all have managed to try this, but the thought process is really about if it is starting at T, and the question is asking for the speed that the car could have at T, what should be present at the start? KE. Right? But is there GPE at the start also? Sure. Of course, there's a height. There's a GPE plus KE at T in order for it to move past S. You see, F at T. Ooh, okay, sorry, no. Okay, from the breakdown of the question here, again, it is released from P. Sorry. Okay, so U again equals to 0. KE equals to 0. Okay, my bad. So there's no KE at the start, only GPE. Can I calculate the GPE at the start? Sure. Jaden, what's the formula of GPE? MGH, what's the H in this scenario? 0.5. Okay, MGH. Therefore, if I want to calculate the speed at the end, immediately link this to, I can do so using KE. Because we know KE equals to R and B squared. Okay, so whatever GPE is going to be transferred to KE because there's no friction. B equals to 3.17 meters per square. Okay, very good. Anyone need a shortcut here? Do you remember this? My equation is right. Equation for example, okay. That's not the first time. Right? I remember last week you also had similar situation. Okay. So I don't know how you key in your calculator. I consider the way you key might be like detrimental. Wrong. Huh? Wrong. What's wrong? Nothing. Nothing is wrong. Then probably you key in wrongly. Okay. So V equals to square root 2GH, right? Can you all try this and see whether you all get the same answer? You remember this shortcut? V equals to square root 2H is actually a very quick shortcut. V is not equal to 3.17. Sorry? V is 3.16. Really? No. 0.2 times 10 times 0.5 is 0.6. Yeah, 0.6. Then how? 0.1, 0.12, not 0.2. The mass is 0.12. You wrote 0.2, yes. Okay, so 0.06. Okay, so nothing wrong with answer here. Do you manage to get the same answer for this? 3.16 is it? Okay, thank you. So let's round to 3.16 instead. Okay, the rounding could have been done incorrectly. And 0. Okay, so B equals to square root of H is actually a quick way. Question can ignore this basically. Do you need the mass actually? No, that's good. You don't have. Okay, this one we have mentioned before when we were discussing content. Again, what can you see from this is actually GH equals to R B squared. I don't need the mass. So don't panic if you don't have the mass in the exam. Okay, let's go. Question 13. Question 12 not easier. Question 13 start to get a little bit difficult, especially the first one. Because the first one is related to dynamics. Keep Lucia, you say dynamics not very sure, is it? Have you managed to try that? Yeah. Okay, thanks. Okay, horizontal forces as the cyclist travels forward. Air resistance, of course, acts against the cyclist. Driving force is produced acting on the back wheel. There's driving force going forward. There's air resistance going backwards. In order for the cyclist to travel forward, Jaden, where's the result? Your backward is this way or this way? This way. Then is the cyclist able to go forward? Wait, my friction is this. Friction? Friction is like this. Friction is acting together with the driving force because this is connected to the engine. So the driving force, you can think of it as the friction trying to pull the entire bicycle forward. So the question is, if the cyclist is moving to the right, is the resultant force to the left and to the right? To the left. Then will he be able to go forward? He won't. If the resultant force is to the left, either he will be slowing down or he will be accelerating backwards. You get it? So do you think driving force needs to be bigger than air resistance? In order for him to go forward in the first place, it must be the case of. Okay, so the breakdown of the diagram over here should tell you, oh, initially at least, driving force must be larger than air resistance in order for him to accelerate forward. Okay. Therefore, in part A, right, bicycle accelerates until constant speed is reached. This is famous question. This one I test you all before now about the person or an object falling through air. Oh. Recall the idea. Run to the bus stop. Terminal velocity, yes. Run to the bus stop. More air hit your face or less air hit your face compared to walking? Oh. More, right? Oh. Yeah. Okay, your O is good. Okay, but I need you to pick up certain key phrases you always need to include in the answer. Okay. My general question to you will be, when I accelerate, what happens to my speed? Speed is. Jaden, what happens to air resistance when speed increases? Very nice. If you can understand this logic, right, half the battle one already. Okay, let's take a look. We need to think in terms of dynamics. Therefore, whatever we have established here must be included in first. In order for the cyclist to go forward, driving force must be larger than the air resistance. Initially, there must be acceleration. First mark. Driving force more than air resistance, resultant force forward, acceleration. What I need to do for this it's not really, oh, exam I need to do this wholesale. Study in terms of exam in general, meaning in general, this is how our answer should be phrased. In general, the forward force is larger than the backward force. Then I link it to, there's the resultant force, forward, therefore accelerate. The blue color stuff, the blue color fonts is going to be able to let you use it in the next question that you see. Okay? So when you study, don't study wholesale. Okay, so that's the first one. As per what Jaden was saying, when speed increase, air resistance increase. Okay, but it need to increase until what? Until air resistance equals to driving force. Okay, before we look at any of the words here, why is that the case? Or I let you write down the blue color stuff first. I'm sharing this on the screen. Okay. Okay. So why is it the case that air resistance needs to equal to driving force? This is exactly equivalent to something falling through the air. Okay, and if you manage to link back to the idea, like what Lucius did, terminal velocity, it's true. Okay, what is the terminal velocity? It is the maximum velocity that I reach. This constant speed here, if you are able to make this connection to, oh, I know that this is terminal velocity. Again, you will be able to answer the question with ease. Lucius, why is it the case that air resistance must be equal to driving force? What does that mean? When air resistance equals to driving force, what is the resultant force? Zero. Zero. So it just stay at the speed. Stay at the speed. Does it stop moving? Or does it stay at the speed? It will stay at the speed. Because you're not taking account of force, right? Okay, yeah. That's why you even if your next speed is just very because additional friction. Okay, if we assume that there's absolutely no friction, then technically I don't have to pedal anymore. No. I mean, no friction on the wheels. There. Mm-hmm. Yeah, it's still. Okay, true. We are saying that the driving force needs to be constantly put in so that it equals to air resistance. Then I can continue moving at a constant speed. Okay, can. What's the formula that you're linking this to say that resultant force is zero, therefore it stays at a constant speed. Equals Rf equals to Ma. I need you to be able to link it to this so that the terminal velocity makes sense. Terminal velocity tells you that the speed is now constant. What does this mean? Acceleration equals to zero. Like what you were saying, sure, you know resultant force equals to zero. But what truly is the formula that ties them together, right? Is really Rf equals to Ma. Okay. From Jaden. So this is the kind of like thoughts you need to put into explanation question. Because I think I have to how calculate this in the next part. You confirm can do. But I need to be able to explain this. So what happens next will be air resistance increase because speed increase. This happens until air resistance equals to driving force. So if you are taking down corrections, I'd really rather you take down the blue colors. Okay, this is the kind of things that you can bring forward to the next question. What happens as a result? Because I know Rf equals to Ma, therefore, resultant force, zero, acceleration equals to zero, therefore, constant. Let's immediately tie this to the idea of a parachutist falling. Done taking this out? Yeah, wait for Lucius or done. Okay, let's tie this to the idea of someone falling down immediately. When we talk about someone falling down, what is the initial acceleration? Again, it's 10, right? No matter how heavy, if me and Adam jump down from building, still 10 initial acceleration. What happens after will be exactly the same. But how will we tweak our answer around so that we can answer the question where something falls from a height? There's mass definitely, okay, but something more accurate than mass is the force that's acting downwards. What's that? Gravity, not accurate enough. Start with W. Weight. If immediately I want to bring you to one of these things. Okay. We recap a little on dynamics from here. Where is it? Okay. This graph is found in your curated notes as well. Okay. But there's something that I want to pass to you today that actually the WA2 okay. You can take a look at page 23. Page 23, you'll find this exact. So for Ian, Tristan, and Brandon, I'll be sending you a soft copy of this notes. And there's already the hard copy that I have here for you. Okay, so I can just ask you the next time. Yeah, I want you to be able to link this to parachutist falling because you cannot write things like, oh, driving force equals to air resistance. This is not true anymore. When something is falling, initially, what happens? When the ball is falling, what is acting downwards, Jaden? Gravity, to be more specific, the one that starts with W, the weight. There will be air resistance acting upwards. Initially, if the ball is accelerating downwards, what can I say about the resultant force? Is air resistance bigger or weight bigger? Weight. Lucian, agree? Is weight bigger or air resistance bigger? Weight. For it to accelerate downwards, weight must be larger than air resistance. Right? What happens when the ball accelerates downwards? become more air resistance, higher air resistance. True. Okay, so the idea is still the same in the sense that, oh, when it accelerates, air resistance increase because speed increases. It increases until what point? Sure. What's the thing? The speed bring down and air resistance bring down. Very good. Okay, I need you to understand that it reaches a point where this happens. Jaded, when this thing happens, right, what can I say about the resultant force? Zero. What does it say about the acceleration? Zero. What does it say about the speed? Very nice. Constant speed. That's why we fall with something called terminal velocity. If there's an even more cheap idea, what if the parachutist that's falling, right? Instead of being a fall, is a parachutist. Then the parachutist decides that I need to open my damn parachute. If not, I will die. If the moment the parachutist opens the parachute, what happens? Velocity is the highest, true, but immediately what happens when I open the air resistance suddenly shifts. There's a super important concept here. When the air resistance is larger than the weight, what exactly happens? It slows down or the acceleration decreases. Slow down. It's not acceleration. In fact, there is negative acceleration. Okay. So this idea, a lot of people can understand. The moment the parachute is open at this juncture here, truly you need to understand that this happens. Parachutist open the parachute, air resistance becomes super large. What does this mean? Resultant force is now negative. When resultant force is negative, Rf equals to ma. If this is negative, acceleration is negative. Negative acceleration equals to deceleration. Therefore, it slows down. We are not done. What happens when it slows down, Adam? What happens to air resistance when I slow down? I start to jump towards the bus. I will be slower, yes. There will be less air resistance. Exactly. Okay. So this idea is not done until you manage to reach the next terminal velocity. After I slow down, again the idea must be, oh, air resistance falls. Until what point, which is until the same again, very nice. So weight equals to air resistance once again. Again, the idea then will be Rf equals to 0. What Gideon was saying, A equals to 0. Speed constant. Is it? Okay, so the big orange portion here, together with what we wrote above in blue, this is exactly what this graph is about. Okay, if you are still struggling with this graph, you need to be able to break this down with the blue and orange colors. Okay, so it's a typical struggle. Let's jump back. Jaden also. Need more time on this? The on top one? The blue color? Is that? Scrub. Jump. Yes. Oh. Something that was already there. Okay. Okay, let's jump back. Okay, so this is the entire idea already. Okay, I just wanted to link it to dynamics so that you are clear once and for all. Let's go to part B. In part B of calculation, let's not spend too long here. Okay, total energy in the kinetic store of the bicycle and cyclist should be quite straightforward. I have M, I have velocity. Can I calculate K? Sure, half mv squared. Done. 600 joules. Okay, did we get the SI unit correct? SI unit of energy should be joules. What's the SI unit for power, Lucius? What's the SI unit for power? Watts. How do I calculate power? F over A, yeah. F over A, not correct. You are mixing up the pressure. Power over time, correct. I'm calculating power. Work done over time or energy over time? Okay, so not calculating power here. In the next part, this is crucial. If Dylan, because you haven't tried this, right? You did. Give the acceleration of the bicycle and the cyclist. What formula do you think I need to bring in here? Young Lucius was asking this, right? So don't say that. Let's just think a bit about this. Because typically I will see like an energy question. Then it's very for you to bring in acceleration as well. In general, you are asking me what is the formula that ties this in, right? Question is B, this one, the B part to O, the acceleration. You're asking me what ties them together. What are some formulas that has acceleration is? V minus U over T, true. Do I have the final velocity and initial velocity and height? No, unfortunately. So I cannot really use that. What else? In dynamics that we were just talking about. Well, I don't. It's coming to Jaden. It is. We were just talking about it. When you say R, when you say resultant force is zero, then you told me that this is zero. Resultant force zero, acceleration zero. What's the formula? R equals to ma. Okay, so this is something that you need to bring to the question here. Okay, knowing that is one thing. From this yellow color stuff that how to calculate R. What's the resultant force from here, Jaden? 30 Newton, 20 Newton. What's the resultant force? 10. I'm done. R equal to ma, 10 equal to mass times acceleration. I can calculate acceleration. Oh, that's really yeah, the difficult part is really about bringing the idea of RF equals to M. So this F net equals to MA, typically we call it RF equals to MA in this class. Okay, but if you like to write F net, it's perfectly okay. F net stands for net force. RF is resultant force. Both are the same. Let's see, bicycle moves, energy transfer. 20 joules lost, some energy supplied to the back wheel. How much energy supplied to the back wheel, Agam? 3 Nice. Because energy can neither be created or destroyed. Therefore, the 20 joules lost must be 380 joules supplied to the back wheel. How to calculate efficiency then in transferring energy? So input over the output over the total. It's always the output input. The energy is it the one that put or the one that in your denominator? Denominator is the total input or output. Output, not right. Input. Okay. So this one like might be a bit counterintuitive because we always like to think like in then out. Okay. So the idea is really about how much effort you put in versus your results. Efficiency is there. Okay. So the efficiency, I don't even need you to like always tell me the output or input. Then I was really like just like trying to test whether you can imagine this out in thing. Okay, but this 400 minus 20, 380 is what we were calculating here. This is your output or input. This is your output. This is the result that you get. But the amount of effort that I put in was 400. If your efficiency is 100%, you should always get the result based on the effort that you put in. Right? So if I put in like 100% of my studying effort, then I get 100 marks out of it. Means my efficiency is 100%. Yep. So this is really output over total input. So the 400 joules is the input, 95%. Okay, I'm good. Let's go on to the last one. Last one is challenging. You all managed to try this with you. Yeah, I gave this question as a 10 for my exam course. Okay, and a lot of them died. Okay, the idea is really not easy and you have to follow along closely. A woman of mass 70 kg, bungee jump. Okay, the bungee jumping, in the end, the question says this. Okay, starts from a bridge above a river. Sure, she's starting from this point here. The moment she jumps down, or rather, at that stage, at point A, what energy did she have? Yeah, GPE lah, right? It's just When the moment that she jumps down, there will be other energy being considered. If being an elastic current, what do you think is the potential? Yeah. Elastic potential energy. This one not talked about a lot. Okay, but once there's something elastic, it's nice. Okay, height A is not so difficult yet. Okay, but good news is air resistance is negligible. Height of the woman is also negligible. Basically, she's just like a particle. Okay, let's go. Height A. Position A she falls from where? GP is negligible. What do you think? Or what do you mean? The height of the woman. What when she falls? Okay. Again, falls from rest means what? Rest is zero. What's the initial speed symbol? U equals to zero. Get what the conclusion from this? No speed, true? Means energy. Ke equals to zero. Very nice. So initially, really only got GPE from A. Next, position B, then the clock stretch, momentarily stop at C, then she bounced back up to D. Part A is still okay, determining speed and position B. Okay, but this one is you need to truly understand it is the change in GPE compared to just the entire GPE. At position B, Lucius, what energy does the person have for this position? Just and I mean along with some GPE, but also negative. It's true, and this idea is really important. There will be some GPE left over, but there will also be kinetic energy when she falls from A to B. Okay? Therefore, the important thing is 50 meters. Did we manage to get this? This 50 meters is truly the change in the GPE. Okay? There's an alternative method. Oh yeah. There's an alternative method for sure. Can you calculate the total GPE she had at A? Yeah. How? Just 80 meters. 80 meters MGH. MGH 56000 joules. Air resistance is negligible. What is the total energy at 6,000 joules? Jaden, what is the GPE at position B? 70,000 times 50. Times 50? Times 30 or 50? This is 30 meters. The height that she was at is 30 meters. This is true. Therefore, the GP is actually this 21,000 joules. Richard, what's the KE? What's the KE? KE is just 50,000. Okay, so this is one of the methods that you could have adopted for height. Use the second method. Okay, I will introduce to you the second method. But the breakdown of the question, right, in part A, if you struggle with this in exam, the moment you see speed in energy questions, immediately you should be thinking, oh, I need to use KE for sure. Because I need K equals to half mv squared. Okay, so the second method looks as such. The change in GPE equals to the change in KE. Therefore, the height that we are using here is 50 meters. Okay, to put it very simply, you don't need to write this entire long statement. All I need to write is change in GPE equals to change in KE. Then you can go ahead with your 70, 10, 50 equals to your half mv squared. Then you solve for it. Okay. Or if you are even faster, you want to use v equal to square root 2gh, go ahead. You will still arrive at 31.6. Is it 31.6? Yes. Yes, I okay. No, it needs to scroll up for the first method that we're talking about there. You see the web? Yeah. Okay. Yes, what's up? Ah,
Then and and the B as only 21 movement. And let's say KG is the something like so is 25 equals how much?
Yes,
That
absolutely right.
oh
Yep. So if you are joining, if you are watching the recording and you didn't hear what Lucius said, right? Yep, and Jaden as well. Right. The first method we are talking about, Jaden.
yeah.
Okay. The KE, right, that we are calculating here is equals to 56,000 minus 21,000, 25,000. How will you find the speed from this, Jaden?
Because K equals nothing squared. Because that K
25,000 KE equals to half mv squared. Okay, so this is the first method we're talking about. This is the slightly longer method. So, answer key given to you is more straightforward method. Okay, but both can arrive at the same answer. Let's look part B. This is not easy. Elastic potential storm when she's at position C. Importantly, what happens at position C? Lucius, is there KE at position C?
they no like no any yes.
No, no, and then yes, correct. Okay, because at position C, she came to a momentary stop. This means that speed equals to 0. KE equals to 0.
When everything is yeah.
Is it everything? No. Once again, is it everything? That's the trick for this.
Oh yeah, it's still a studio.
Yes, exactly. Right. There's still this annoying 6 meters. That what the heck, why this woman never just go into the water? The woman goes into the water, then yes, all the GPE is instant potential energy. Okay, so that's the key difference. Alright, so that's part B. So the elastic potential energy again will be the change in GPE equals to the change in elastic potential energy. Okay, that's why this is MGH. And that's why this is 74 meters. You got it? Very nice.
It's still wrong questions.
How what?
All questions.
How is where this far? Oh, don't understand how it's hard. Wow. Yeah, I need to tell my sec course this. Today my sec 3 say, this question very yeah, like, shit, feel than that. If you make use of our first method once again, right? Again, at C of Jaden, what's the energy that's present? We say that there's no KE. So what are the energy present? GPE and ET. Okay, I think you get the idea. Shall not go through this right now. Okay, let's move to the last one.
E is 21,000 units. Then the KPE at B is 25,000 units. Start with that is because A is a solve.
No. Again, because at C, you still have a bit of GPE left. If you are saying that I add these two together,
Minus
and then minus, yeah. So you add these two because it was already at the start. Okay,
so
so
it means minus
can exactly. So you can use 56,000 to minus GPE at C. Jaden kind of went straight that. Okay, let's go. I think Jaden got already. Easy answer. But see, elastic potential stop at position D is smaller than at position C. Is this logical? What's your answer, Adam, for this?
string and D is not stretch more than string C.
String and D not stretch more than string and C. Some truth in it, but doesn't really capture the essence of energy transfer. Lucius, what's your answer? Have you tried this? Jaden, you think about this coming to you soon. Hey, you haven't tried it. Hey, how come you never copy down the answer? Lucius, how come you haven't copy down the answer?
We got
Sure. Okay, I will send the answer key lah. Question.
shorter is common sense.
Huh?
Shorter is common sense. It's less stretch.
It's shorter, less stretch, true. So what in terms of energy, what energy is present at C compared to D?
There's no speed.
More G.
Yeah.
Okay, so this is an energy question. That's why you need to relate like energy. Okay, although sometimes like you're probably like Lucian, like so stretch more means for more, stretch less lah. Okay, true. Okay, but if you relate to energy, right, you need to be talking about a position D. There is
Some of the elastic
sorry,
some of the elastic principle.
yes, from position D to C. Yes. Okay. So whole idea to this sorry, C to right, C to D. Yes. Okay. Whole idea to this answer here is simply GPE at C is less than GPE at D. Therefore, EPE at C is larger than EPE at D. If you can bring home this concept, then it's either good. Okay, so it's actually the last question. 540. Okay. Okay, do you want to bring worksheet two?
Yeah,
They go together. Okay, then we move to worksheet two for a bit first, because I don't want you to halfway through take a break or anything like that. Okay, so we are going to go on with one more question to discuss. Then you will start your second half of the quiz. Actually, last week's quiz, the 10 MCQ that we did, I purposely like cut the quiz into half. Because the quiz at the back actually still got a structured question. That's why you're only there for 10 MCQs. Okay, but this week is going to be about structured questions as well. Okay, if not, let's go into energy worksheet 2 for a bit. You can go over to question 11. MCQ, I think we have already discussed. You can study question 11 first, opening it up soon. Again, I want you to be obsessed with the breakdown. I won't allocate time for you to try or anything, but you can try to break down the question on your own first. What are some things that you have picked up from the question that you will definitely need? About 20 more seconds. You go ahead, you can go discuss. Okay, fine. I'm pretty certain that you picked up things like that too. Okay. The biggest mistake you can make right in exam is you see the question, you then kanchiong, you go to the diagram, then you should start to answer the question. Okay. So don't jump to part A first, break down the question first. You might be finding hidden gems in it. Okay. Number one, mass 50 kg. Mass 50 kg, again, I can calculate GPE, I can calculate KE. Okay. Position A at her lowest position is to rise. Okay, the lowest position, what does this suggest to you? GPE minimum. If start to rise, fastest position B with a speed of 8 meters per second. Lucius, what does this tell you? I can calculate what?
sure.
KE, there will be KE because there's speed. Maximum position C. Again, what does this tell you? Position C has the maximum what? Very nice, maximum GPE. If you can bring down a question like this, you're more than happy. If you want to write down, perfectly okay. Okay, let's go on. State the flow of energy stored in the stretch spring as shown. Okay, this one I think no problem. You probably know elastic potential store. Okay. Can you write elastic potential energy? Cannot. Okay, because we're talking about the store concept. Let's go. Part B. Moving through a height of 0.3 meters from A to B. A to B 0.3 meters. What can you say about this? Can you calculate from this in fact? Kinetic energy. MGH. So what about MGH? If you use MGH here, what are you calculating?
That's it.
The elastic potential energy. Considering the transfers in energy, amount of energy in the store stated in A. Okay, so this 0.3 meters, yes, okay, sure, you are using mgh. So is this the change in GP? Yeah. Is it? Okay. 50 times 10 times 0.3. What are your answers to this? One, one, sorry? 150 joules, is it? Okay. Super important question now. Wait for Jaden to prepare expect about. Okay. Is this 150 joules everything elastic potential? I ask again, is this 150 joules all the elastic potential energy? Someone says no. Because from what I was hearing now, you all were saying, this GP all transfer to the elastic potential energy. True or false? Where's the height? From A to B, this is the height, 0.3. Again, let's be very obsessed at each position. What does she have? It is just the elastic. It is just the elastic potential energy. At position A, what energy does she have? Or does the whole system have? Elastic potential energy and maybe a little bit of GPE, depending on whether we know this small height or not. Yeah. Right? At position D, what does she have? Sorry? GPE. There's also KE. Can you see where we are going with this? Whatever that you calculated in this 0.3 meters, is it just the EPE? It's actually not just the EPE. Why? Because sure, initially it was EPE. With this 0.3 meters change in GPE, it is not just GPE change, but rather there's also increase in kinetic energy. Therefore, whatever she had at position A is going to be transferred to both the GPE as well as the KE. If this statement makes no sense to you, you need to check now. Because I think some should say, oh, only the EP. Does this make sense? Jaden, okay with this? Okay. So whatever the MGH that we calculated here, 150 joules is only the GPE. There's also KE that we saw because there was an initial speed of 8 meter per second.
Wait. Ground share connected in change GPE equals MGE. So that 150 is just the change in GPE. Not EE.
From position A to B. Yes, the increase in GPE.
Oh,
Fact is, at position B, she not only increased in GPE, she also has KE at that position. Therefore, the elastic potential energy, right, needs to be a lot more so that she can achieve that position.
so you think the EPE plus GPE change equals to
The EPE equals to the GPE change plus the KE change. Basically, this one looks like this. In short, elastic potential energy at A equals to the GPE at B and the KE.
where is GPE at
Where's the GPE at?
A?
At A?
Yeah.
We didn't take into account because that small height is the same for position A and B.
Yeah.
Mm-hmm. So to be a bit more precise, change in GP. Yep. Very nice, very nice. Start to link this idea up. Later you will need it.
Yeah, because the EB is the one that's pushing
Correct.
so
Sorry?
like the EB will go with
Correct. The stretch in the spring is pushing it up and making it the same. Sorry. Very nice, very nice. Do you calculate the final answer? 1750. 1750. Can I double check with everyone? In case Adam's calculator wrong. Later everyone write down this answer forever. Okay, but the final answer I really don't get. If you can get the method, very good. Okay, if you are done with this part, you already move on to part C. Okay, calculate distance moved by the gymnast from B to C. Okay, this one I give you approximately 1 minute. You try to solve this. Okay. Once we are good with this, we'll start our test.
Hoặc cơ quan làm triệu khi cái khi mà vào nó là
At where?
oh wait. So you're taking the ground to just do and then
Position point, is it? At this?
yeah, the point.
You can be thinking that way, although you should keep in mind that there's a bit of height.
Yeah,
We are taking this more like a reference, zero. That's okay.
oh, so the GPE that G is just using 0.30
Yes. In fact, that's the gain in GPA, to be
Yeah.
more precise.
what else? In KER, it's like
Right? 30 more seconds to sum up. Even if you are good, you can try plenty. I think there's one more question. Okay. We should have bring calculator again. Why ah? Ian gave me quite a good reason really.
I felt really bad.
Okay. Okay. Okay, so for those who were not able to do part C, right? Okay, again, the obsession is the breaking down of the question. At position C, what does the gymnast have? Genesis managed to get the answer. Position C, what does the gymnast have? GP. Any KE? What KE? It should reach a maximum height at position C. Don't have what?
All the KE.
To be more precise, cannot say convert anymore. Nah.
So it's 1 like it's 1
The height, we are calculating the height. Yes, 1750. Jared, sorry, why is there no GD at C? Why is there no K at C? Why were you so sure? Maximum height, what does it mean? The speed equals to 0. Yep, go correct. Speed equals to 0, therefore no KE at position C. So whatever KE at B was transferred to GPE at C. Okay, therefore the distance moved should look like this. Okay, in short, can think of it as also change in KE at B equals to change in GPE at C. Therefore, you can calculate the distance. Is this gain in GPE the total GPE that the gymnast will have at position C? I ask you now. Is this gain in GPE the total GPE at position C? Why not?
because if it's supposed to be all
All the what? The forces.
other
All the stores combined. Okay, so if you are only talking about this KE being transferred to GPE, you still need to take into account the GPE that the gymnast had at position B. Okay? But if you manage to get this, sure. Part C is really about the change in KE. Okay? So whatever that the KE transferred, it will all go to the GP. Therefore, height will be 3.2 meters. Okay, so 3.2 meters is only this. So it is not the total GPE that he will have. Okay, let's move to part D. Some of you already went on to try. Another male gymnast, greater mass, passes B with a speed of 8 as well, reaches his maximum height at C. Is this male gymnast going to reach a larger height? Or rather, the distance moved will it be bigger or smaller? Hmm? Will be the same. Lucius, what answer, please? Or Jaden, then you were thinking about this as well, right? Auntie. What's your answer? I mean, what do you think?
it is different from
Why would it be different? Why would it be different? Your revision is fine. Okay, after this, we are having a break. Okay, so give me your last like, 2 minutes.
just lower
Lower. Your logic to this is
because uh like like even
okay. You think about it. You say you when now you say it's the same again. Jaden,
if you know
huh?
lower
Heavier go up lower. Okay.
because it's the same.
Okay. But I thought half md square will affect the m. Right. So the k seems to be more, right? So is it going to jump out like further?
See, yeah,
Probably going to be less. Okay. So you are changing your answer here and then. Jaden, can I hear your answer first? Do you think you will go up more, go up less, or go up the same? And have some like logic to it as well.
and it's more.
You think same logic behind it? Your reason?
Not solid.
Okay. More weight. More weight. If okay, if I rephrase that a bit, like larger mass. Are you linking this to amount of KE? Greater mass, then you feel that KE up mv squared. Then I will, if the velocity is the same, mass bigger, KE will be bigger.
Yeah.
KE bigger at position B means that you will be able to jump further to a higher height at position C.
Higher
Hmm?
because if n is B is the same, right? Half is the same. If K is more,
KE is more, that's true. What about the GPE? How do I calculate GPE? MGH? The mass is now bigger. What do you think happens to the height?
yeah,
Lower. Right? So that the GPE, even though the KE at the start is more, right? Okay, but because of the higher mass, the height is going to be affected.
that's all.
Right? Okay? So answer to this. The idea is still the same. The change in KE equals to the change in GPE. Half mv squared equals to mgh. N therefore will not be a factor because half v squared equals to gh. The height will therefore depend on half v squared over g. Everything stays the same. That's why the height that it moves also the same. So Yeah, so the M can be cancelled. Makes sense.
Oh, sorry.
Okay, so the whole conclusion to this, the change in height really depends on the initial velocity. Okay, if velocity is bigger, indeed the person will move higher.
So wait, so distance is still the same.
Distance in feet by is the same.
So
You're correct.
yeah, this are mathematical calculations. I could explain that this use mathematical.
Mathematical calculation, you will get the state mark for sure.
Oh,
So the mathematical calculation will be a bit tricky, will be quite risky. Lah. Okay, so you should explain in terms of words, bring in some equations, prove that indeed this is not proof, only V will affect. Yeah. Okay. All right. I'm good with this. Can I assign 12, 13, and 14 as your homework again? Energy worksheet 2 shall be 12, 13, 14 both. Okay, Jaden.
um, probably not me.
Doom scrolling, Jaden. Okay, I'm super guilty of it also. Okay, but 12, 13, 14, let's do it as homework. Okay, because what will happen right now is your break followed by the second half of the energy test, okay, which consists of structured questions. Okay, let's do this. Do you all prepare your energy test, the MCQs? If you got it, you can have stable parameters as well, distribution. Yes. Rest your brain cells first. Okay, don't jump straight into it. And don't start reading the question first. Okay, there are a total of 4 questions. Okay, we will start at 6:11. Okay, now it's 6:09. Rest up your brain cells. Okay, you cannot refer to any reference materials. Okay, see whether you can input whatever you have learned into this note. Correct.
It just only
There may be some instance of dynamics within, maybe only. If so, not to let your guard down. Okay. Let me open up a timer.
maybe
Hmm?
I mean
The max I will give you is half an hour. I'm thinking we can have 25 minutes for a start. So that we have more time to discuss. We see whether you manage to finish first. Okay.
well
Sorry?
one
Huh? Cannot do? Oh no, why? Then what you want to do? Want to move on with more revisions, huh? Check. Cannot, sorry, Jaden. 加油. Okay. We will do this for 25 minutes, guys. Can I do anything to make you feel better, Julian? Cannot. Okay. Okay. We ready to go? Okay, let's start. We just we need my calculator.
You have you have and you have you get this. Is it actually? Is it? Is it? Is it Chico? Is it Chico? He's serious? Yeah, that's Chico. He's the killing shit. He's not inside the actually. Today, right? Yeah, yeah, silo. It's like the whole holiday is just Chico. Okay. Yes, if I did it, Chico. Okay. How much time will you? Huh? How much time will you push? Sangyu. It doesn't know. Sangyu can, but you can also use to Akasu. You don't know to find. After the VA question, okay, 25 minutes. Where did you all manage to finish until? Jaden seems to have finished most, but then we left some questions blank. For Jaden, yeah, if you do that in exam, I think very likely that you won't do well again. Yeah, so we need to tackle those questions for sure. Yeah, but I think you need to give it a shot, especially if you tell me about that, right? Then you really tell me it's so. I think then you need to go and try it. I think you really can do that. You managed to finish the question 13. 14 blank. Agak English 14 haven't finished. Okay, can. Okay. I'm not so interested in the tabulation of the results here. I'm more interested in the breaking down of the questions and the way you approach the questions also. Let's see. We discussed the questions a little, especially for those you are not sure of. Mm, yeah, okay, let's discuss questions a little first. Let's see.
Okay. Can we discuss question four? Again, the breakdown of the question, right? If you were struggling with part A, then you're trying to think of a bit more complicated stuff. Again, the breakdown of the question should look like the following. Conversations finish at 13 because need to speed up a bit because set 4 is the speed that is expected. For about 4 questions, I think 25 to half an hour is the standard that you need to reach. Okay. Fact is, in question 14, I see you all don't really like to like break down the question. You like read through, then you like go and try it. Okay. So if you are struggling with which things to pick up, immediately, right, you should pick up things like, oh, mass. Again, remind yourself, I can calculate KE if I'm given the speed. Indeed, wow, shit, jackpot, I'm given the speed. Can I calculate KE? Confirm can calculate KE at P already. At P, the position P, I'm able to calculate KE using half mv squared. Okay. Friction along the ramp, this one is I need you to be able to apply work done against friction. Okay, before you even jump into anything, Jaden, I want to ask you this 2.5 newtons friction, right? In which direction? This direction up. Nice. Okay. How can I calculate the work done against friction? You know work done is energy, right?
Yeah.
Kinetic plus gravitational minus friction. The idea is correct. More of I'm asking in terms of the green color values that you got. 2.5 newtons. Can you do to calculate work done with the force given? How do I relate work done and force together?
That's possible systems.
Very nice. Work done equals to force times distance. In this case, work done against friction. What do you think is the force? The friction force. What do you think is the distance? I need to move in that route, right? Then I can experience the friction. So what's the route that's moved now? The hypotenuse of the PQ. Correct. So this dr is actually the PQ. Is it? So this is how you calculate work done against friction. You are thinking of the correct stuff already. Because you are telling me, so I think that the K here, right, compared to the K at the bottom, something has to do with the work done against friction because they dissipated into the surroundings. Okay. So let's check the first part first. For Lucian, I don't think you will struggle with the first part, but let's follow along. Kinetic score, half mv squared, that 2.25 joules. Question is this. The next part is the challenging one. You have correctly identified what you need to do. Right? You know, sure, I know pseudo must come in. Okay, so you told me that what you saw was I have the opposite and I want to find the hypotenuse because that's what the question asked me. Question says, I want to find the distance traveled. Right? Distance traveled by the box from P to Q is literally PQ. If you use Tuakaso here, how does Tuakaso work? Is it you forget so you didn't try this? What is Tuakaso? So is sine, right? So sine what? Sine 30 degrees equals to O over H because so much Tuakaso. Have you learned Tuakaso? Yes, Tuakaso is a sec 2 concept, right?
Really?
No?
Yes.
Yes, right. Sec 2 learn before, right? You're sleeping in sec 2. Okay, so your first one. Oh, you can. Okay, so the O over H. What is the O?
H over H.
Hmm? What 2H? The opposite is 2H, man? Yeah. It's just H, man. Right? What the hypotenuse? I have no idea. I want to try to prove, but I'm not sure yet now. So I want to try to calculate the hypotenuse. H. What's sine 30? Make sure your calculator is in degree mode. 0.5. You see where we're going with this already? Hypotenuse therefore equals to 2h. That's why your d equals to 2h. Proven. Right? So technically this is not really sine rule, this is more of like your hustle. And I pick out the correct one to use, I'm using slope. Okay. Okay. I think this is the one that maybe stumps some of you. And if you were asking me about this, right, then maybe question 13, you were also thinking a little about this. Let's break down question 13 together also. In roof of bungalow constructed using ceramic tiles, one pile of mass 300 grams. Again, pick up things like this. Do you think I can use 300 grams straight? Do you know? What should I do to in order for me to fit it into a formula? Cannot sure we use grams now. The SI kg. Okay, so whatever that you want to use, right, remember that you need to convert to 0.3 kilograms. Okay. And slide down the rule from rest and shown. Again, keywords like this. Lucius, what does this mean?
Okay. Like no kinetic or like no initial.
No initial kinetic energy. So what is the symbol that we use for initial? Velocity, u equals to 0. Okay, very nice. U equals 0, therefore Ke equals to 0. Okay, experience constant friction force of 0.4 newtons and slides for 3.5 meters. Again, just now I already asked Jaden this question. Let's throw it over to you, Lucius. What is the work done against friction?
I think like 0.4 times 3.5.
Very nice. Work done against friction. Yes.
So maybe like
Equals to 0.4 times 3.
no, my answer is very Chinese.
Okay. For Jaden, I haven't seen your answer for this. Okay. But what do you think initially the tile had? The initial energy that the tile had when it was at the plus K. Was there K at the start? How was initially? Yeah. No K at the start. Why?
Rest.
Very nice. From rest, K equals to 0 at the start. Okay. Yes, definitely there's GPE in the tile here. How do I calculate the GPE? I have the ground. I need to make sure I have the height. What's the height? There's a sorry, 15.8 is it? Yeah. So you this 15.8 means you get sums up. Really? 15.8 is therefore not correct. Jaden, what do you think I can use this for this one?
Continuous and so sine 5.
Sine 35.
Sine 35 equals to opposite over
Opposite over 3.5. Very nice. Okay, and I can calculate the opposite to be sine 25. Sine 25 times 3.5. Lucius, do you do this? Sine 25 degrees times 3.5.
Yeah, I got sine.
What's the answer?
I'm 1.47916.
Thank you.
Oh,
Opposite therefore is this. Okay. Jaden, I literally told you this word. So it's not lost or destroyed, but cannot be created or destroyed, but can be transferred from one store to another. And the total amount of energy in isolated is all constant.
I guess it's cos.
You use you use cos. Okay. So it must be like Jaden like that. Term that you know so well. But Jaden knows so already, then you never apply. Yeah, so very close, guys. Calculation mistake when you try to use the sign, is it? Okay, so you just added up the height plus the distance, right? Because you were doing 15.8. So 15.8 not correct.
No, it's not that I didn't use Skype. It's just that when I told it's just wrong. I just too long.
Okay. Okay. So if your idea is correct, you should arrive at 4.5 meter per second. Again, the shortcut to this, once again, if you don't want to write this long as first statement, can just write like that. Change in GPE equals to change in KE plus work done against friction. Again, why do I not need to consider KE at the start? Because there was no speed at the start. Okay, so 4.5 meter per second. Jaden, you managed to get this.
Yeah,
You got it?
yeah.
Okay, nice. So you use sine rule for this. You use the slope for this question.
Yeah.
Why the next question never use?
Well, first like
Oh, because of the H. Yeah. Okay, okay. Wow, nice. So, okay, yeah. Okay, but question 14, let's check our answer for C as well. Okay. Do you all manage to do this? That one ran out of time. Jaden, you managed to do C for question 14? You did. Can I check the answer first? 0.4 you get this?
yeah,
You got it?
0.45.
0.15. Okay, wow, nice.
Why your space that is? I feel my friction.
You didn't find friction?
Yeah.
Then how do you manage to get it?
I took the kinetic because the Q is the moment. So I put K equal to me.
Ke equals to GP.
Yeah.
Oh, so the change in GP equals to the gain in K.
Yeah.
Okay.
Mine equal to MGH.
Okay.
Yeah. Then
you added.
now that
Yeah. That cannot be true though. No, you managed to get 0.45. I'm so confused. Right. No, because for those watching the recording, right, Jaden's method was he says that the change in the GPE equals to the change in the correct. Sorry, but then they also done against friction.
yeah, I need friction. I want
You did nothing of 2.5 times 2h.
it. I see 9 equals 2000 plus each. Then 9 equals 20 each equals so and
Okay, I need to see your working a bit more closely.
oh I okay just 3 steps.
Okay, wait. Total energy work done against friction, overcome friction. Okay, if you manage to get 0.45 by what Jilton did, without considering the word against friction, most likely you will only receive 1 mark, if not at most 2 marks out of 4. Okay, and this is usually termed as like fluke. Okay, but I need to see whether it's really a fluke or not by thinking a bit more, not really looking, because I know what you read. Okay, so let me look at your working a bit. Let's check our answers for, let's see. Okay, we check our answers first now. Question 11. About the American general thing. Okay, American general. Sorry. This one easier. If the general picked up bullet and feels quite hot, energy changes for this internal force transferred from the work done against friction. If or simply there was work done against friction as the bullet. If part B, 5,000 joules. Easy, kinetic torque. You got this? Part C, kinetic torque as well. Given the speed, can you just calculate kinetic torque? You good? Okay, how much internal torque produced? 490. Sorry?
And then I want
10.125.
yeah. So I want to see answer.
Correct? So 10.1. 10.1 can accept as well.
Oh, what is that?
Sorry?
What's one?
Why 1 accept?
No,
No, this one should be 2 accept. 10 is actually 2 accept.
no, what is that?
1 accept is below 10, but 10 can also be 2 accept. In physics, the final answer don't leave it as 1 accept. So either 2 or 3 accept.
Where is it?
Wrong, typo.
Oh,
Internal core produce therefore to be 4990. Easy, is it? Okay. But this one part E, I don't know whether you all managed to link it to what I wanted you to link to. Jaden, this was a question that you left blank, right? Part E. Jaden, part E you left blank, right? So do you manage to link it to RF, or rather, or in this case, work done equals to force times distance, right?
oh, I didn't use our. Oh,
So work done here, force times distance, yeah, force times distance. Okay. So work done is the total energy that was used to move through, or rather block the bullet. Okay. So the work done in total was the 4989 that we calculated here in the internal storm. Okay. So the average opposing force, the fact that we moved 10 cm, 0.1 meters, I can calculate the opposing force. 49900 meters. You good with this? You got it? Okay. Okay. Question 12. Shall I collect your papers? I want to see your workings for everything. Okay. Okay, for the last 10 minutes or 6 minutes or so, I want to look deep into one of into the things that I have. Alright. Alright. Oh, something. Alright. Continue. Yeah. I don't think. Yeah, right. I don't know. Yes. Will you go back and look through this? Yeah. You will have a I haven't met any. I feel ancestors. Okay. Thanks. Okay, can we look into the very thick booklet that I just passed to you? Wow. Huh? You want to what? You want to go already? Sure, it's coming in 5 minutes. Okay, for Jaden, before your WA, then you ask me for this one. Eh, where is it? Answer. Do you manage to watch the video already? Before the W okay. Anyway, this was the booklet that we use for the W2 revision. Okay, I thought that it will be good for us to attempt some of the questions inside. Okay, we won't run through the content anymore. Okay, maybe the content we will link it to some of the questions here and there. Okay, but there are many questions inside that are very worth discussing as well. Okay, and I want to jump straight into dynamics actually. Okay, so if you can follow along with me to page 24. Page 24. Can you attempt question 1? We discuss and we should call it a day. I think some of you are still struggling with dynamics. I want to pay more attention to this.
And there's a good.
Mm-hmm.
And there's a lot.
For W3?
Yeah.
Oh, okay. Okay. For Agam, it will be that. But for your EOY, definitely will have. You have your WFC topics ready.
I think it's just
You have an answer ready too.
right.
You can move on.
I think it's just pressure.
No, it's not.
It's
Credit.
pressure is
Energy.
and it's the next part.
The thermal one.
Yeah.
Okay. Okay.
My teacher actually wants to start it like right in front of this. Then everybody told them I'm going to see house. Next so the yes.
Like all your classmates say don't want.
Yeah. So basically the teacher must was from I Yeah.
It's supposed to be next turn and Hey, try question one.
Suppose started okay. When they ask, do you actually understand how long which and then everybody said you correct so. Yeah.
Yeah, okay, come on. Question one, done already? It's on page 24, right? Oh, you're going at the page numbers. Oh, I'm so sorry. It should be this question here. So, you all see this question? Jaden, have you changed your answer already?
Yeah.
What's your answer? Try again. Think again.
Yeah.
Huh?
Yeah.
Think again. You don't have so many chances in exam. You need to be able to answer me. That's. You know when you find this question? Sorry, I think I missed out. Not missed out, like the setting put wrongly. Didn't manage to clean up the pages. Jaden, you can move on to question two. What?
Obviously B.
You think it's B?
Yeah. Obviously the wrong one, right? Obviously B.
Which of the statement is not true?
Oh.
Ah.
Oh. Oh.
So much confidence there. Jaden, why do you think it's A?
First, the rest of
The answer correct. So what is wrong about
you. But it's so obvious that it's C. Obviously C.
C is not true, is it?
The magnitude is not true.
The magnitude is the same.
Yes, C. Obviously C. Wait. Mm,
Okay. We will go through this and we will come up. Question one answer is A.
yeah, yeah. Because the faster you go, the more air resistance, right?
Correct?
Yeah, so the C is not. So A is true.
So what?
So C is actually true.
C is really true.
Yeah.
Okay.
I'll consider this.
Okay, but why is A wrong? So why is A wrong?
Mm.
Accelerate at quantum rate with different magnitude.
What magnitude?
Magnitude is the size of the acceleration. Acceleration.
Actually, rate of acceleration.
Okay, I think A is phrased a bit strangely. Okay, so if you understand that B, C, and D are true, then I'm okay. But why is it the case that R reaches the ground first?
R is greater than S.
R is with the mass. What does it say about the terminal velocity?
It's more.
Okay, things that I want you to bring out of this question are not just the correct answer. True, as for what Lucius said, R is heavier. What does it say about terminal velocity?
R.
Okay, Lucius, bring this one. R as greater. For Jaden as well. Greater. Last one already. Come. Terminal velocity.
Because it's more mass.
Because more mass,
Yeah.
which result in more
More terminal velocity.
more terminal velocity. Not directly, we have some missing gaps there. Higher mass equals to higher weight.
Indirectly, yeah.
Okay, if you have to explain all, then you need to fit in the missing gaps now. Okay, but if you understand this, then we know. Okay, this booklet you can do you I will ask you all to bring back. Do you all want to leave it here or you want to bring back again?
Yeah, I'll be.
You leave it here? Can you help me write your name? Jaden, do you want to bring it back or you want to leave it here? Because the notes inside is a good summary for the front part. You bring it back? Okay. You sure? Put it here. Okay, I'm also to bring it. Try to revise certain front topics in front. There's pressure inside also, but you don't. Okay, at least try to like. Okay, yeah, no, we will sum up today.
But I want to know three factors.
Like the end questions inside.
Who knows that is very exciting. Very
Okay, lah, fine. You can keep each other if you want to. Okay, so thanks Ian, Tristan, and Brandon for watching the recording. I hope you will watch this because I need you to try the test as well. I'll be dropping the soft copy version on Telegram chat so you can try it on foolscap paper first. Okay, I will see you all next week. Peace.